All right, let's try this. Okay, we're good. Okay, let's get started. I don't think today's going to be too long of a lecture. 1.5, there's just a couple of questions. I guess there's a decent amount from there. So what is 1.6? Oh, that one's kind of important. Okay, yeah, let's just get started. So this first stuff, is this recording? Okay, we're good there. All right, so this is section 1.5. And so this whole question, or this whole section is just about, solving equations for x. So let's go through just different examples of what we need to do here. So how about something like, no, we could start basic and then work our way up. So number 5, we want to solve 4x plus 3 equal to 0 for x. We've sort of been doing this for the past couple of lectures anyway, but for some reason there's a section in the book that's just talking about equations like this. Anyway, but we know how to solve this. Like all we gotta do is get x on one side, everything else on the other side. So let's just copy it down again. So to get x on one side, the first thing we need to do is move the 3 over. So we're going to subtract the 3. And then we're going to get 4x is equal to 3. And then the last thing to do to get x alone is we need to divide by 4. And then that's going to give us x is equal to 3 over 4. All right, so nothing really too crazy about that problem. Let's move on. Let's do a couple more. And we can do some ones with fractions. How about like number 9? We have 3 minus 1/4 x is equal to 3 over 2. All right, so basically it's the same, solve for x. So it's still the same idea as the last problem. We've got to get x alone on one side. And so to start this problem here, we have this 3. Let's subtract it over to the right-hand side. So we could subtract a 3, subtract a 3. So then once we do that, we get minus 1/4 x. That's going to be equal to 3 over 2 minus 3. And then what we're going to do is get a common denominator. So we can just rewrite this right-hand side, leave 3 over 2 the same, but then we can turn that 3 into minus 6 over 2. So now we have a common denominator. So we can just subtract the top. So 3 minus 6, that's minus 3. So we have minus 3 over 2. So rewriting this just with less equal signs, we have 1/4 x on the far left-hand side. That's going to equal minus 3 over 2. All right, so now we need to get x alone. So there's a minus 1/4 on the left-hand side. So what we need to do is multiply both sides by negative 4. Let's move this arrow over. So at this step, what we need to do is to get rid of this 4 on the bottom on the left-hand side. So we need to multiply by a minus 4 on the left, and then also multiply by that minus 4 on the right-hand side. So on the left-hand side, those minus 4s cancel, and we're just going to have an x. And then on the right-hand side, we'll have, so a minus 3 times a minus 4, which is a 12, divided by 2, and that's going to be equal to 6. So we get x is equal to 6. Okay, let's do number 10. So 10x minus 3 is equal to 8 plus 10x. So when we have these type of problems, still the same thing as always, just get x on one side and something else on the other side. There'll be a number on the other side. So here we have x on both sides, so we just got to decide, just move x, one of them to the left or one of them to the right, doesn't really matter. So we can just move this 10x over to the right. Let's solve for x. So what we can do is just move one of the 10x's over to the right. So notice if we do that, we'll subtract a 10x, subtract a 10x. What we get on the left-hand side is a minus 3. On the right-hand side, we'll have an 8, but we're getting, see, we have 10x minus 10x, so that just goes away. So we end up doing some work, and we get to this step, we see minus 3 is equal to 8. But this is not true. Minus 3 doesn't equal 8. So whenever we get a situation like this where we have a number equaling a number, but they're not the same number, that just tells us we have no solution. We can do it actually, let's do this. I'm not sure which one in the book. Do we have one like this? Oh yeah, we don't need to make one up. Let's do one that's kind of like the opposite of number 10. So, which is number 16, which says we have minus x plus 1 is equal to 1 minus x, and we want to solve for x. So in this one, same thing, let's just move all the x's to one side. What we could do first, let's just take this minus x on the left and just add it, and we'll add it over to the right-hand side. But so kind of like in the previous example, those x's cancel out now on both sides. So on the left-hand side, we just have a 1. On the right-hand side, we have a minus x plus an x. That goes away, so that just equals 1. So this is a different situation, whereas in number 10, how we had a number equaling a number, but those were two different numbers, which is an untrue statement. We got no solution, but here we just get 1 is equal to 1. And whenever you have a situation like this where a number is equal to a number, this means we have infinite solutions if the number is the same thing. So here we have 1 is equal to 1. Whenever we have a situation like that, that means we have infinite solutions. Or I guess in particular, just the solutions are all real numbers. X can be any number. All right, let's see. We can do 20. So we have 5x minus 4, or sorry, to copy that. Yeah, 5x minus 4 is equal to 2x plus 5. All right, so for this, let's, just like always, let's get the x on one side and then a number on the other side. So solve for x. So what we could do here, let's just take the 2x on the right-hand side and move it over to the left. Subtract the 2x, let's subtract the 2x. In doing that, so on the left-hand side, we'll have a 5x minus a 2x, which is a 3x. There's a minus 4, let's just rewrite it. So now the 2x's cancel on the right, and we just are left with this 5. And now what we can do is we'll take this 4, add it over to the right-hand side. So we have 3x is equal to 9. And then the last thing we can do is just divide both sides by the 3. All right, so x is equal to 3 for this one. Let's do that. Let's see, it's 20. Yeah, 26 is fine. Let's do that one. All right. So let's combine solve for x. So before we move any x's around, let's just combine all the like terms on both sides of the equal sign. So you notice on the left-hand side, we have a 5x minus a 2x. That can turn into a 3x. And just rewrite the 17. On the right-hand side, we have a 6x and a minus x. That can turn into 5x. Rewrite the minus 1. And now what we can do, let's get the x on the same side. Let's subtract the 3x from the left over to the right. Okay, so the 3x cancels on the left-hand side. We just have a minus 17 now. On the right-hand side, we have a 5x minus a 3x, that's a 2x, still the minus 1. And so now what we can do is we can add that 1, or let's cancel the 1 on the right-hand side. So let's add the 1 over. On the left-hand side, now we have a minus 16. The right-hand side, we still have the 2x. And then the last step, let's divide by the 2. And then that gives us minus 8 is equal to x. Okay, let's do 27. So 27 says we have 7, 3x plus 6 equals 11 minus x plus 2. So for this problem, the first thing we're going to want to do is we want to get rid of all the parentheses. So we need to distribute all the numbers that are in front of the parentheses. So for this first one, we'll distribute the 7 across. So we're going to get 21x, and then 7 times 6 is 42. And then on the right-hand side, so we'll have that 11, and then we have to distribute the minus sign. So 11 minus x minus 2. And now let's combine like terms on both sides. So there's no like terms on the left-hand side. Just rewrite that as 21x plus 42. And then on the right-hand side, so we have an 11 minus a 2, which is a 9, and still the minus x. And now let's move this x over to the right, left-hand side. So let's add the x, add the x. So what we get is 13x plus 42 is equal to 9. And then what we can do is subtract the 42. And see, 9 minus 42 is 33. So we get 13x is equal to minus 33. Number is 27. Okay. And did we make a mistake somewhere? Did I copy this problem down right? Anyway, let's see. So sorry, the book says the answer is minus 3 over 2, but this doesn't simplify to minus 3 over 2. How does the book get that? It might be a typo, right? 7 times 3, so it's 21. Make sure I copy everything down right. Yeah, so you got 21, 7 times 6. Pretty sure that's 42. That's right. So then 11 minus x minus 2. Okay, that becomes a 9. That's fine. Add the x, that's 13. Give me 1 second. Let me just do something real quick. Oh, I see what I did wrong. I turned this 21 into a 12. Sorry, I wrote these numbers backwards. That's the mistake I made. See, this is a 21, but I wrote a 12 here. That needs to be a 21. I just wrote the numbers backwards. Sorry. Let's erase all this. That's where the typo came from. So yeah, I wrote this needs to be a 21 here, not a 12. So when we add x, we get 22x right here. And then we still have the plus 42. That's equal to 9. And then we, just like before, let's subtract the 42. We get 22x is equal to, what was that again? So 9 minus 42 is minus 33. And then we can divide by the 22. And then we're going to get x is equal to minus 33 over 22. And then that simplifies to minus 3 over 2. Sorry about that. Yeah, so the little typo that was right here. I wrote a 12 instead of this number I wrote as a 12, not a 22 or a 21. Okay, but yeah, here's all the correct steps. Okay, let's move on to the next one. How about we could do 20, or let's do 30. So 4, 3x plus 2 minus 7 equals 3x minus 2. Oh, I didn't see the comment until just now. Thanks though. Okay, so we gotta do here. So same thing as last time. Let's first, whenever we have these parentheses, let's get rid of the parentheses by distributing the numbers in front of them. So on this left-hand side, let's distribute the 4. So we have 12x plus 8. We still have the minus 7. And then we have 3x minus 6 on the right-hand side. So now let's combine all the like terms. So on the left-hand side, nothing to combine with the 12x, but we have 8 minus 7. That's going to be 1. And then on the right-hand side, we have 3x minus 6. And so now what we can do is let's subtract the 3x. Let's move that over to the left-hand side. At the same time, too, let's subtract that 1 and put it over to the right-hand side. So on the left-hand side, we have a 9x. And now we have these 1s that cancel. Okay, so nothing over there. So now on the right-hand side, we have these 3x's that cancel, and then minus 6 minus 1, which is minus 7. And then the last step would be to divide by 9, and we have x is equal to minus 7 over 9. All right. Let's just do a couple extra. That's basically all we need from 1.5. We have been solving other, like before in sections like 1.1 to 1.4, we had to do like quadratic equations. Let's do a couple of those just so it's kind of all like just a bunch of things solving for x. Because the book requires you to already know how to do that. But then for some reason they have you do this section, which is only solving linear equations for x. But just so we can have, like a couple of examples. Say if we want to solve an equation like, just mix them up real quick, like x squared plus 7x plus 12 is equal to 0. So when we're solving these ones, we need to factor the left-hand side. So this might be just a good places to like explain more in depth of like to refresh you guys on how to factor. So there's several situations in factoring. This is one situation where the number in front of x squared is equal to 1. And when that's the situation, well, then there's two situations here. Sometimes we can use the quadratic formula. We can write that down. This always works. So say if we have ax squared plus bx plus c is equal to 0. A way to always solve this equation is just with the quadratic formula. X equals negative b plus minus the square root b squared minus 4ac all over 2a. So this way is always going to work, but we always want this to be a last resort because it takes a while. We have to do this square root thing. There's fractions involved. It takes a long time. But if we could, the first step is always to see if we can factor. Let's just put this off to the side. So when we're doing this problem up here, the x squared plus 7x plus 12, whenever we have a 1 in front of the x squared, which we do in this situation, the first step in factoring is let's first just write these two parentheses. We'll have an x, and then an equals 0. And then what we can actually do is let's put just plus signs here. And now we're going to want to put a number here and a number here. So what those two numbers need to do is they need to multiply up to 12, and they need to add up to 7. So just off to the side, we can just start let's write down 12. So we need numbers that multiply up to 12. So what are all of our possibilities? 1 and 12, we got 2 and 6, we got 3 and 4. We have -3, -4. The list goes on. but we need to make sure they add up to 7, the middle number. So this one's not going to work because if we did 1 plus 12, that's 13. This second one's not going to work. 2 times 6. 2 times 6 is 12, but if we add those, we get 8. So that's not going to work. But then we go to 3 times 4. So 3 times 4 is 12, and 3 plus 4 is also 7. So this one is going to work. So we're going to plug a 3 here and then a 4 here. And so then that's just the first step. That's how we can factor x squared plus 7x plus 12. So the next step is once we figure out how to factor and we set it equal to 0, we have these two pieces, this piece and this piece. Those are both multiplying together, it's equal to 0. So what that means is we just set both of these pieces equal to 0. So we get x plus 3 is equal to 0, and x plus 4 is equal to 0. So this one we get x is equal to minus 3, and over here we get x is equal to minus 4. All right, let's do another problem like that. So maybe something like x squared, let's do minus 5x, then plus 4 is equal to 0. So like before, we have a quadratic. So before we even think about using the quadratic formula to solve it, we want to see, can we factor it? Because like I said, we always want to factor. That makes things a lot, saves a bunch of time to do that way. So we have a 1 in front of the x squared. So then that just tells us that our first step for factoring is always just to do this. X plus equals 0. Now we're looking for a number to put here and a number to put here. So remember, we always want to multiply up to this number and then add up to that number. So what are all the possibilities that multiply up to 4? Well, we got 1 and 4. We got 2 and 2, minus 2, minus 2, minus 1, minus 4. Those might be the only ones. So we need the ones that multiply up to positive 4 that add up to minus 5. So 1 plus 4 is positive 5. That one's not going to work. 2 plus 2, that's 4. That doesn't work. Minus 2 plus minus 2, that's minus 4. That doesn't work. But see, minus 1, minus 4, that is minus 5. So this one does work. So this pair right here, minus 1 and minus 4, if we multiply those together, we get positive 4. And if we add those together, we get minus 5. So those, we're going to plug in a minus 1 right here and a minus 4 right here. So we can kind of simplify this here. You see on the left-hand side, we have an x plus a minus 1. That's just the same thing as x minus 1. And here we have an x plus a minus 4. That's just the same thing as x minus 4. So this equals 0. So at this step, we set both of the pieces equal to 0. And here we get x is equal to 1. And here we get x is equal to 4. All right, I need to get a piece of scrap paper. I need to come up with this next example real quick. Okay, so let's solve this one. 6x squared plus 5x plus 1 equal to 0. So now this one's a little bit different from the previous problem because we don't have a 1 in front of the x squared. We have a 6 in front of the x squared now. So we still want to try to factor first. Always want to factor first before we use quadratic formula, but this is, we're going to have to do a little bit different of a method for factoring. So when we want to factor this left-hand side, we want to do something called the AC method. So remember, this is kind of like related to, let's write this off to the side. So let me write this. How do we want to do this? Before we actually write this problem down, let's just talk about how do we factor with the AC method. So say if we have something like this, ax squared plus bx plus c is equal to 0. And in this situation, a does not equal 1. So how we factor this one is, first what we're going to do is we're going to take the numbers a and c and multiply them together. So we take a and c, so a multiplied by c. Now what we want to do is we need to figure out what are all the numbers that multiply up to a and c. So we're going to write those down. Let's say we're just going to write one of them down. We'll call it u and v. So we need to find these numbers u and v. So these numbers u and v need to have two properties. So we need to find u and v. Now these u and v's have to have two properties. U multiplied by v, this has to equal a times c. And the second property is going to be u plus v. This needs to equal b. And so then once we find these two properties, what we're going to do is we're going to rewrite this equation. So we'll write this as ax, so we have ax squared plus bx plus c. We're going to write this as ax squared plus u plus v x plus c. And then we would distribute this x in the middle. So we'll write this like this: ax squared plus ux plus vx plus c. And then once we get to this step, we're going to do group factoring. So it's kind of hard to see this when we're talking in pure variables, but once we get to this step, this last step, it's kind of apparent what we need to do. So this is sort of just like a quick little like schematic of how we do the AC method. So let's do it with that one problem that we were just talking about. So we want to solve 6x squared plus 5x plus 1 is equal to 0. So we want to factor this left-hand side. We need to use the AC method because we have something like this. We have ax squared plus bx plus c is equal to 0. And we have the number in front of x squared, the a, that's not equal to 1. In this situation, our a is equal to 6. So if you look at the AC method, what we have to do is multiply a and c together. Let's write it. So here we have a is equal to 6, b is equal to 5, c is equal to 1. So we need to multiply a times c, which is 6 times 1. So we have 6 times 1, that's equal to 6. So now we need to find the numbers that multiply up to 6, but then add up to b. See, that's what we're doing right here. We need to find two numbers, u and v, that multiply up to a times c, and then add up to that middle number b. So here's a times c. We need to find the numbers that multiply up to that, but also add up to the middle number, which is in this situation 5. So the first thing to do, just regarding that adding up to 5, let's just figure out what are all the numbers that multiply up to 6. So we have 1 and 6, we got 2 and 3, minus 2, minus 3, minus 1, minus 6, and I think those are all of them. So we need to find the ones that, these are all the numbers that multiply up to 6, but there's only going to be one of those pairs that add up to the middle number 5. It's not this first one. If we add those up, we get 7. It is going to be the second one. See, 2 plus 3 is 5, so this is good. So this is the pair that we need. And if you notice, the rest of them don't. So minus 2 plus minus 3, that's minus 5. Don't want that one. Minus 1 plus minus 6 is minus 7. Don't want that one. So there's only going to be one pair that works. So we found our pair. So 2 times 3 is 6, and 2 plus 3 is 5. So if we look at our previous, the schematic up above, we can say that we can just let like u be 2 and v is equal to 3. So this is like from the notation from above. So then what you see what we did is we rewrote our middle term b as those two numbers instead added together. So the next step we do now is we're going to rewrite this. We'll have 6x squared. And instead of writing 5, we're going to write 2 plus 3. X plus 1 is equal to 0. And then the next step was to distribute this x through the parentheses. So we're going to have 6x squared. If we distribute the x, we have plus 2x plus 3x plus 1 is equal to 0. And now this is where we said we need a group factor. So once we do it in this step, it doesn't matter. And also it doesn't matter which order. You could put the 2 in front or the 3 in front. That doesn't matter. All you have to do is just rewrite that middle term as the u plus v thing. So what we're going to do now is we're going to group this 2 together and this 2 together, and we're going to factor just those two separately. So notice from this first pair, we could take out a 2 and an x. So if we took out a 2 and an x, we'd be left with a 3x plus a 1. And then there's nothing we can factor out from the second term. We're just going to rewrite that as 3x plus 1. So again, notice here, just from this first group, the common terms between those is a 2x. So we could take out a 2x from this first one, we get 3x. And if we take out a 2x from the second one, we just get 1. So if we were to multiply this 2x back through, we should get 6x squared plus 2x, which is what we do get. 2x times 3x, that's 6x squared. And 2x times 1, that's 2x. Okay, But now with this piece right here, notice we have another thing in common. This term right here has a 3x plus 1. This term just has a 3x. So we could factor out a 3x plus 1 from both of these guys. So let's take out a 3x plus 1. So from this first term, we're going to have a 2x left over. And from this last term, we're going to have a 1 left over. So if we were to multiply 3x plus 1 back through, 3x plus 1 times 2x, that's 2x times 3x plus 1. And 3x plus 1 times 1, that's 3x plus 1. Okay, and so now we're done. We just factored it. So this is set equal to 0. And now we set both of the pieces equal to 0. And so from this one, we get 3x is equal to minus 1. And then we would divide by the 3. So we get x is equal to minus 1/3. And this one we get 2x is equal to minus 1. Divide by the 2. X is equal to minus 1/2. Okay. Let's do one more, like AC method one. Let's come up with one real quick. Okay, so let's solve this equation. 14x squared minus 3x minus 2 is equal to 0. So in this problem, same thing. We want to see if we can factor first. We always want to avoid the quadratic formula. So we are going to have to use the AC method because the number in front of the x squared, that's not equal to 1. So we got to start with the AC method. We can just write that down again. So A here is 14, B is minus 3, and C is minus 2. So if we start by doing A times C, that's going to equal 14 times minus 2. That equals minus 28. So first step, let's just think, what are all the numbers that multiply up to minus 28? So we have 4 times minus 4, 8, 16, no, 4, 8, 12, 7. So minus 4 and 7, 4 and minus 7, 2 minus 14, 14, 2. There might be others, I don't know, but the first one's going to be the one that we need. So notice here, well, not that, actually the second one. So we need the numbers that multiply up to minus 28, but add to the middle number, which is B. Minus 4 and 7, if we add that, we get positive 3, but we need a minus 3, so that's not going to work. 4 and minus 7. So 4 times minus 7, that is minus 28. But if you add those together, you get minus 3. So this is the one that we want. Because remember, we want to make sure. Sorry, 1 second. Need to. All right. So we got 4 minus 7. Anyway, so 4 plus minus 7, that's minus 3. So that's the pair that we want. So what we're going to want to do now is rewrite this equation. So we're going to rewrite 14x squared minus 3x minus 2 equals 0. So we're going to replace that minus 3 with a 4 minus a 7. So rewrite the 3 as 4 minus 7. Oh, sorry. We need to be a little bit careful here. So we're going to need to turn this plus, this minus, because we need to make this a little bit more apparent here. That's a minus 3. So what we're going to do is rewrite minus 3x. We can rewrite that as minus 7x plus 4x. That's how let's do it like this. So we have this minus 3 here, this minus 3x. We're going to rewrite that as minus 7x and then 4x. because minus 7x and plus 4x, that is minus 3x. So now what we're going to do is group these first two together, group these second two together, and now we'll factor from both of those. So from this first one, we could take out a 7x. So take 7x from 14 x squared, we're left with 2x. Take 7x from minus 7x, we're left with a minus 1. And then from the second bit, we could take out a 2. And then we're going to be left with 2x from the 4x, and take out a 2 from minus 2, you're left with minus 1. And now notice that we have this term in common, 2x minus 1, 2x minus 1. So what we could do is take that out, 2x minus 1. And what we're left with from this first term is going to be a 7x, and from the second term is going to be a 2. So now what we do is we set both of these pieces equal to 0. So we can add the 1 over. We're going to get 2x is equal to 1. Divide by the 2, x is equal to 1/2. Here, subtract the 2. 7x is equal to minus 2. Divide by the 7. X is equal to minus 2 over 7. All right, that's good for this section. Let's move on to 1.6. So what we got going on here. Oh, that's 1.5. All right, 1.6. All right. So this is just going to be, before we were doing equalities, these are going to be a bunch of inequalities. So for example, let's just do some examples here. Like number 1, we want to solve, so 4x minus 3 is bigger than 2x plus 7. So we want to solve things like this. For the most part, all we do is treat this greater than sign or the less than sign, greater than or equal to, doesn't really matter what it is for now. Just treat it as an equal sign. Maybe you remember that if we divide both sides by a negative, we have to switch that sign. We'll get to that in a second. So for now, actually we can do that in this problem. Let's start by moving this 4x over to the right-hand side. So we can still do the same things, like add numbers, subtract numbers, multiply numbers on both sides. So first, let's start by subtracting this 4x over here. All right, so then on the left-hand side, we'll have a minus 3. Solve our bigger than sign. We have a minus 2x plus a 7. Okay, so now let's subtract the 7 over to the left-hand side. Subtract the 7, subtract the 7. So what we have is a minus 10 bigger than minus 2x. But we need to solve for x here. So what we need to do is divide by the minus 2 on both sides. But whenever we divide or multiply a negative, this sign needs to turn around in the middle. So minus 10 divided by minus 2, that's positive 5. But since we divided by a negative, we need to turn this sign around. And then those minus 2's on the right-hand side cancel, and we just have an x. So just writing up the side. So whenever multiplying or dividing a negative number, you need to flip the sign. Which is what we did right here. Okay, and so in this, we several ways to write this answer. So here we have, this is x is less than 5. So say if we want to put this onto a graph, here's 5. This is saying, one way of saying this is either x is bigger than 5 or 5 is less than x. What's important here is that it's a less than sign, not a less than or equal to sign. So for sure we have to have an open circle on here. Whenever we have less than signs, we have open circles. And then if we have less than or equal to signs, we have closed circles. And this is saying x is going to be bigger than 5. So if x is bigger than 5, we shade to the right. So that's another way of writing this answer. And then the last way of writing this answer is with an interval. We can do this with a parenthesis, 5 to infinity. So it's a parenthesis because it's an open circle. And then infinity always gets an open circle. So these are all different ways to represent the same answer. Okay, let's do 13. All right, what do we got here? Minus 3 over 4x bigger than or equal to minus 5 over 8 plus 2 over 3x. All right. Well, one thing we can do here, we got to get the x's, always we got to get the x's on the same side, and then just numbers on the other side. So one step, let's get the x's over to the right-hand side. Let's add this 3 over 4x. Let's add the 3 over 4x. And at the same time, let's move this minus 5 over 8 to the left-hand side. So plus 5 over 8. So now on the left-hand side, so those we got rid of the minus 3 over 4x. We're just going to have a 5 over 8. And all we're doing is adding, subtracting, so the sign's not going to change. The sign only changes when we're doing multiplication. I mean, it only changes if we're multiplying by a negative number. We haven't done any multiplying yet. All right, so that's good. On the right-hand side now, those 5 over 8s cancel. So let's just write what we have is a 2 over 3x plus a 3 over 4x. So we needed to get, let's see, make sure there's no typos so far. 3 over 4, 2, 3, 3 over 4, 2. Okay, so what we need to do is get a common denominator on the right-hand side. So how we can rewrite this is, let's rewrite this right. Let's not do that. That's kind of confusing. Let's do a new line. So we'll have 5 over 8 bigger than or equal to. So the common denominator, which is going to be 12. So we will have, let's see, for an 8 over 12x plus, and then so 9 over 12x. So that's just fine. Our common denominator is 12. So we have to turn these fractions with denominators of 12. So on this left-hand side, or this one right here, we multiply the top and the bottom by 4. And then on this one, we multiply the top and the bottom by 3. Okay, so now we have the same denominator, so we can add them together. 5 over 8. So we have 8x plus 9x, which is 17x. 17x over 12. All right. And now what we can do is multiply both sides by 12 over 17. So 12 over 17. Let's move this arrow over. So the 12 over 17 on the left-hand side, or the right-hand side cancels. So we just have an x. And on the left-hand side, is there any simplifying? Oh, let's write, well, so you notice there's let's just use a calculator. It's okay to do. What do we have? So 12 times 5, yeah, whoops, like that's 60. So we have 60. And on the bottom, we have 17 times 8, which is 136. See, how do we simplify that? What goes into, does 4 go into that? Yeah, so 4 goes into 136 34 times, and then the 60 go into 4. Yeah, so 15 over, let's make sure we don't make any mistakes here. No, it doesn't give us the answer. I think that's as simplified as we can go, because 3 doesn't go into that, 5. Okay, yeah, so this simplifies into this. So we have x is less than or equal to 15 over 34. So if we put that onto a number line, the way of writing that is, here's 15 over 34. Now it's a less than or equal to sign, or it's just less than, or it just depends on how you're saying it. We can say this is 15 is bigger than x, or x is less than 15. But anyway, the sign has that or equal to part. So because of that reason, we have to have a closed dot. And so now let's figure out where are we shading. Well, it's just saying x is got to be less than 15 over 4. So less than means we shade over to the left. All right, so there's the thing on the graph. If we put that into an interval, we'll have minus infinity all the way up to 15 over 34 and a bracket because we have the closed dot. So these are all the same answer, just written in different ways. All right, let's talk about, let's do 15 together. So this is saying we have 4x All right, so the first thing we're going to do here is we can't, so we need to get rid of the parentheses on both sides. So the first thing we have to do is just distribute everything. So on the left-hand side, we're going to have a 4x squared minus an 8x. On the right-hand side, we will have a 2. Let's first FOIL. If we FOILed out these parentheses, we would have a 2x squared. Let's see, a minus x, so minus 7x, and then a plus 3. Is that right? So we'd have a minus x, a minus 6x, and then plus 3, 2x squared, minus 6. Yeah. Okay, now the next line, we'd have 4x squared minus 14x plus 6. Okay, so now let's get all the x's on one side and then the numbers on the other side. So let's move everything over to the left. Subtract a 4x squared, subtract a 4x squared, add the 14x, add the 14x, and that's all we need to do for now. So on the left-hand side, those 4x's cancel, and then we have a 14 minus an 8, which is a 6x. And on the right-hand side, those 4x's cancel, the 14s cancel, and then we just have a 6. And so then all we need to do is just divide by 6. So divide 6, divide 6. Then we get x is less than 1. So on a number line, here's 1. Open circle, x is less than 1, so we shade to the left. And that relates to this interval, minus infinity all the way up to 1 with a parenthesis. Okay, next questions. Let's do 18. So find the domain of the square root of x plus 8. So remember that whenever we're finding the domains of the square root, so say if we have the square root, does anything on the inside, this blob is just, it could mean anything. When we're trying to find the domain of it, all we do is we take that inside, which is that blobby thing, and just set it bigger than or equal to 0. And then we solve this inequality. So that's all we need to do when we're finding domains of the square roots. So in this situation, our blob is just x plus 8. So when we're trying to find the domain of the square root of x plus 8, we just take the inside piece, which is x plus 8, and we set it bigger than or equal to 0. And then solving for this inequality, we get x is bigger than or equal to minus 8. And this is going to be the domain. So writing this on a graph, minus 8, we have the or equal to sign, so this is a closed dot, and it's saying x is bigger than that. And so we shade to the right. And that into an interval is going to be minus 8 all the way up to infinity. Okay, next question. How about let's do, yeah, 19 is good. So again, find the domain. F of x is equal to square root 1 minus 5x plus 2. So we need to find the domain. So remember this domain, I guess another thing too that we talked about before when we were trying to find the domain, there's only two things we ask ourselves. Are there fractions and are there square roots? And if there's, in this situation, we have a square roots, there's no fractions. So if you remember last time we were doing domain, we always took the bottom of the fraction, figured out where that is equal to 0, and we weren't allowed to be that number. In this situation, there's no fractions. All we have are square roots here to worry about. This 2 doesn't really do anything. That's not going to affect anything with the domain because the 2 is not a fraction and this 2 is not a square root. So there's nothing really, that can't cause any trouble. Remember, the only time we have trouble is if there's a negative inside of a square root and then a 0 on the bottom of the fraction. So in this situation, all we have is just this square root piece. And just like before, we've got to set the inside piece bigger than or equal to 0. So we set this 1 minus 5x bigger than or equal to 0. We can add the 5x over, so we get 1's bigger than or equal to 5x. Divide by the 5, so we get 1 over 5 is bigger than or equal to x. So that on a graph, here is 1 over 5. Closed circle because we have that or equal to sign. And this is saying x is less than 1 over 5, or 1 over 5 has to be bigger than x. So if x is less than 1 over 5, we shade over to the left-hand side. And so our domain is going to be minus infinity all the way up to 1 over 5. And so this is sort of important here. We're allowed to plug in negative numbers into this equation. It's just this whole number itself can't be negative. But notice if you plug in the number like minus 100, that number on the inside is a positive number, so that's okay. The only issue is that this whole number as a whole, that's what this is saying right here. That inside piece, this whole piece right here needs to be bigger than 0. Not necessarily that x needs to be bigger than 0. We see right here, x is allowed to be any number less than 1/5. So, you know, minus 100's over here. So we're allowed to plug in minus 100 into this equation because if we plug in minus 100, it just so happens that this time this number is going to be positive. So that's one thing to keep in mind when you're doing the domain of a square root. It's not that x needs to be, you know, bigger than 0. It's that whole inside piece. In this situation, 1 minus 5x, that needs to be bigger than 0, bigger than or equal to 0. Okay, so here's all of our equivalent representations of the domain for this one. Let's do 22. 22, yeah, 22. Okay, so let's find the domain of this one. This is a little bit different now because we have the square root in the bottom of a fraction. So first, let's just write the instructions, find the domain. Now let's write out those questions. You know, last time we did domain, we said two things. Are there fractions? Are there square roots? These, whenever you see this word domain, these are always the first two things that should pop into your head. They're equivalent. If we're trying to find the domain, this is another way of saying, okay, where is their fractions, where are their square roots? And because those are the times we have problems. The domain is, if you're in the domain, there's no problem, meaning you can plug it in and you don't get an undefined. Remember, we have undefineds with fractions if we get just any number divided by 0. We can't have that. And with square roots, if we do square root and we get a minus, minus number, a negative, let's write that as a negative number. So these are things we can't have. So we can't have, these are both things that can't happen. So we have to make sure these never happen. And then we get rid of those numbers and the rest of the numbers are in the domain. So in this problem, we do have fractions and we do have square roots. So let's look at let's take care of the fraction bit. So you remember with fractions, the bottom can't be 0. So what's the bottom of our fraction? Well, the top of the fraction is x. We never care about the top of the fraction. All we care about are the bottoms of fractions. So the top of our fraction x, that doesn't really affect anything. But the bottom of our fraction, square root of 8 minus x, that can have we can have an issue there. So we can't have the square root of 8 minus x equal to 0. This can't happen. So let's see, when does that happen? So if we want to solve this equation, well, we can square both sides. So now the square root goes away. We have 8 minus x. This can't equal 0. Let's make those 2's a little bit nicer. Okay, so let's add the x over. So we get 8 is not allowed to be x. So for sure, this can't happen. We can't have x be 8 because when x is 8, well, then the bottom of the fraction is 0, and we can't have that. All right, so now let's take care of the square root part. So you remember, whenever we have a square root, the inside always has to be bigger than or equal to 0. So what's the inside of our square root? Well, if we look at our problem, we have a square root. It's square root of 8 minus x. The inside of it is 8 minus x. So we need 8 minus x to be bigger than or equal to 0. And if we solve for x here, that means we need a to be bigger than or equal to x. So we have these two conditions. Here's the first condition, x is not allowed to be 8. And this condition is saying just x has to be less than or equal to 8. So let's put these onto a number line, and we'll see there's something important that happens here. Notice how this one says x is allowed to be, this is saying x can be less than or equal to 8. So if we were just to graph this part, it would be, here's 8, we'd have a closed dot, and we would shade to the left. However, we have to take both of these things into consideration, this piece right here and this piece right here. Whereas the bottom piece is just saying that x has to be less than or equal to 8. That or equal to means we can have a closed dot. But however, this one is saying x is not allowed to be 8. So in this situation, we actually have to make this closed dot an open dot because we're not allowed to be 8. If we are 8, then the bottom of the fraction was 0. So in this situation, we have to take both of them into consideration. So doing that, we get this. So this is saying that x has to be less than or equal to 8. So we can be less than 8, that's okay. But this first bit, the fraction one, is saying x is not allowed to be 8. So we get rid of 8. And so this is going to be our domain for this problem. So if we put that into an interval notation, it'll be minus infinity all the way up to 8 with parentheses. And like another way of saying that is we have to have, so x is less than or equal to 8, and x can't equal 8. So all these things mean the same thing. This and is important. The and means we take both of those things into consideration, and we take the common between the two. And the common between the two is this graph and the interval notation that we have over here. Okay, what else we got in this section? All right, let's do a couple more problems. So we got, let's do, how about 24? So here we have minus 3 less than x plus 2. Less than or equal to 5. So in order to solve these inequalities, we want to get x alone in the middle and then just numbers on the outside. So the only thing that's making x not be alone is that plus 2. So let's subtract 2. Subtract 2, turn on 3. So on the left-hand side, minus 3 minus 2 is minus 5. In the middle, we have just an x. And on the right-hand side, we have a 3. So this is going to be, let's put this into a graph. So here's minus 5. Here's 3. So this is saying x is bigger than minus 5 with a greater than sign. So we need to have an open dot, and less than or equal to 3. So closed dot over here. And this is saying just x is in between the two. So we have it shaded like this. So there's the graph. And then if we put that into an interval, it'll be minus 5 up to 3. How about 34? 2 over 3 minus 4 over 5, x minus 3. 1. Okay, so we need to get the x alone in the middle. The first thing what we can do is let's multiply everything by minus 5 over 4. So let's multiply by minus 5 over 4 over here. Let's rewrite the problem. So we're going to multiply by minus 5 over 4 because we want to have that 4 over 5 cancel in the middle. So minus 5 over 4, 2 over 3. And we're multiplying everything by a negative sign, so we need to switch the signs. This sign's going to switch. Minus 5 over 4. This sign's also going to switch. And then minus 5 over 4. Okay, so on the left-hand side, we will have a minus 10 over 12. Those minus 5 over 4, minus 4 over 5, those cancel. So we just have an x minus 3 in the middle now. And then on the right-hand side, we have a minus 5 over 4. Okay, so now the next step to get x alone is let's add 3 to everything. Add 3, add 3, add 3. So what we're going to get here now is we will have 3 minus 10 over 12 x 3 minus, let's write that a little bit neater, 3 minus 5 over 4. So we need to get common denominators on everything. We can rewrite this 10 over 12. Let's just simplify that first. We'll have 3 minus, that's 5 over 6. Greater than or equal to sign. Okay, now let's get a common denominator. So this is going to be 18 over 6. And over here we'll have 12 over 4. Okay, 18 minus 5, that's 13. So we'll have 13 over 6. And 12 minus 5 is 7, so 7 over 4. All right, so onto a number line. Here's one way to write the answer. So on a number line, we have 7 over 4, 13 over 6. So 13 over 6 gets the closed dot because it has the or equal to sign, and the 7 over 4 gets the open dot. And it's saying x is bigger than 7 over 4, but less than or equal to 13 over 6. So it's in between. And then if we put that into an interval, we will have 7 over 4, 13 over 6. Okay. That kind of takes care of everything from this section. Do you have any questions? Are you okay? If so, yeah, we can just end class right now. Okay. Yeah, well, other than that, that's all we need to talk about today. So I'll post this video on YouTube once it's like kind of done loading. Yeah, but other than that, I'll see everybody tomorrow. Cool. All right, thank you.